This will be the first video in a series on special applications of integration. And special application number 1 is calculating the area between two curves. And the big goal here will be to calculate the exact area bounded between two functions on a closed interval. So this is a somewhat long intro to this problem. Take a minute to copy it down if you need to. What we'll be looking at is the following situation. Megan and Will are riding bikes with special devices that can read their velocity in miles per hour at any time t. Megan's velocity over time, the function m of t, is shown on the left graph, while Will's velocity, w of t, is shown on the graph on the right. If both riders have initial velocity 0, how far apart are they when their velocities are next equal? Well, what I'd like you to think about are a couple things that we currently be able to do with this problem with the skills that we have. Let's take Megan's problem, for instance. If this is a graph showing her velocity at any time, then recall what the area underneath that's going to be times 0 when she starts to some time a. Well, this area could be represented by the integral from 0 to a of Megan's rate function m of t with respect to time. And it would give us net change in miles, because her rate of change was in miles per hour. Similarly, given Will's graph, we could figure out the same thing for him. From 0 when he starts to any time b, the integral of his rate function from 0 to b would give us his net change in miles. And so at some point, what we're going to imagine is that these two graphs are going to intersect each other. And that time where they intersect, time c. And for that time, we could think about two things. I could think about the area, the net change for Megan's distance. I could also think about the area or the net change for Will's distance. And back to our original problem, what I'm really looking for is the difference between the two. Visually, we can tell that Megan has a larger area under her graph. She's traveled farther. Will's area is smaller. And the total difference between the two would be this space right here. And thinking mathematically about how we'd get that, it would be the area from 0 to c under Megan's curve minus that area from 0 to c under Will's curve. Or combining that into one problem, it'd be the integral from 0 to c of the higher function for Megan minus the lower function for Will. And if we could solve this definite integral, we would have the difference in net change for distance for the two riders. And so to summarize, and more importantly, generalize, the area bounded between two functions, call them f of x and g of x, on a closed interval a to b, where f of x is greater than or equal to g of x for all x values on that interval, can be calculated by the integral from a to b of f of x minus g of x dx with respect to our axis for the independent variable. And that's all I have for the intro to this concept. And you'll see as you get into working with practice problems, some of the other mechanics you're going to have to consider to solve problems like these. That wraps up this video on calculating the area between curves, and thank you for watching.